There we go. And yeah, Jim, whenever you're ready, take it away.
Yeah, thanks. So this is going to be a little bit of a quick uh, demo slash introduction to what I've been working on. So just a quick poll in the audience. Uh, how many of you guys are familiar with LabVIEW or other kind of node-based programming?
Yep, super
Okay,
familiar. Yeah.
okay, great. So just a little bit about me. So I co-authored LabVIEW for Everyone, third edition, and I spearheaded a lot of open source LabVIEW projects over the years, since about 20 something years ago. I wrote the package manager for LabVIEW and a bunch of software engineering tools for LabVIEW. However, LabVIEW has always been kind of a closed and still is a closed product. Um, and I've been very interested in finding ways to kind of expand this in different directions. And one of those is with AI. And so I'll give you guys kind of a quick demo here of some LabVIEW code. I'm going to drop a while loop and then create a control to stop, create an indicator, and then I can run this and very quickly, because there's no delay, you can see how many iterations the loop ran. I'm going to now place some other nodes, like for example, if we wanted to write to a file, and I'm going to quickly get to the AI part, promise. Okay, so I'm going to wire through here. I'm not going to make these a shift register just because my ID is slow and I've only got about 7 minutes. So hopefully when this wheel stops spinning, I'll continue. So I'll let you guys know. So what I've been working on over the past couple of years, I kind of took some interesting detours to try to generate text-based representations of the graphical code, and specifically kind of dumping it kind of into a JSON format and really trying to figure out what are the best ways to have text-based representations of graphical programs. So behind the scenes, this is all saved in a binary format. Each of these things is an object, wires are objects, wires connect to nodes via the nodes terminals. And LabVIEW has its own reflection library. So using LabVIEW, you can get a reference to this module file called a VI. You can get a reference to its diagram. The diagram has objects on it. Objects have different types and a type hierarchy with properties and methods, things like that. So you can traverse the graph of objects that way. And so let me just try to run some of the AI integration stuff that I've been working on. So I'm going to attempt to, so I'm going to start some code that I wrote. So the under the hood workings of the AI integration are in Python, because that's what a lot of the libraries are written in. And so one of the tools that I've written for LabVIEW is essentially a bridge between Python and LabVIEW. And so under the hood, we have exposed the entire reflection API to Python. So Python can actually access all of these objects. I think I shared a video of actually having an assistant conversation with the code. Like I can ask it even verbally with recording audio, like, how many nodes do you see on the diagram? Hide the label of the while loop. And it can, using the tools API, it can essentially interact with these objects for live editing. So hopefully in a second,
Just
this
while
will,
we're waiting, I'll burn some question time and jump in
yeah.
here.
Mhm.
Um, give you a little bit of cover. Um, what is the what kind of information are you sending to the AP or sorry to the AI? Is it like a text? Is it that textual representation you were talking about? Is it using like a vision AI? Like, are you sending the actual pixel data? Um, what's that look like?
Yeah, yeah, yes, and yes. So this is all still kind of evolving very quickly. The first iteration of this, so I just invoked a cleanup operation on it. And so the way that the cleanup operation is working here, if we look under the hood, is it's generating a prompt,
Hmm.
recommend new node positions for the diagram according to the stated rules. And so we have a list of strings for the rules, and then we have a diagram, which is an object. If I cruise over to there, I think that this model, yeah. So the diagram is a model that has a list of nodes, and nodes have a type, for example, like a while loop or a sub VI or a primitive function. They have a unique identifier, which is how they can be referenced by the LLM to let us know that it wants to reposition something, and we pass it size. And so when we generate this prompt, if I can get back to the prompt, so we essentially generate a prompt, and then we're asking it when we send it, we are asking it to uh, give us a response model of this list of new node positions. And then when that runs, you can see I've kind of dumped the prompt here, and it's not extremely well formatted. Hopefully you guys can kind of read that, maybe making it whites a little bit easier. And so you can see the prompt says recommend new node positions, yada, yada. And then here you can see the rules are essentially like a new line delimited list. And then the diagram gets rendered as JSON.
Okay. Yeah.
And so these LLMs, especially like OpenAI with Code Interpreter, have great JSON, Python support. I've also done work in transpiling these graphical data flow programs into text-based representations. It gets a little tricky for parallel async stuff, but it can be done pretty easily for sequential stuff. And so that allows, for example, even transpiling snippets to Python and then sending that as additional context. So to answer your question about is this text, is it images, we also have been playing with augmenting this JSON context with a screen grab of the selected nodes and passing that as image data that's essentially a base 64 encoded URL, which is a valid sort of URL format where the data goes directly with the image. And so you can provide all this additional context to the LLM so that it can use a combination of vision, code interpreter, and other stuff in order to do the work it needs to do. And then there's
And
an mhm.
which model are you sending it to? Which or models are you
So
playing with for this?
I've mostly been playing with GPT 4.0 and then the Claude 3.5 Sonnet now. And then
Cool.
so then the other thing that can be done is to tell the LLM that it has tools. And so when we send a prompt, part of the APIs are we can say, oh, and by the way, you have a tool. So when I'm asking you to do this, if you tell me you'd like to use this tool, here are the arguments to the tool. So you can send me a request for more information, and I'll send you back data in a certain format. And so that lets the LLM, if during its reasoning realizes that, oh, hey, this tool would be helpful, or this tool would be helpful, like I'd like to ask you to do these calculations locally because they're faster. We can then do those calculations and pass back the data. Or instead of taking return data and us manipulating the objects on our side, we can actually give it tools to directly manipulate objects, which is a little bit dicier. But that's essentially the kind of the toolbox that we have here. So on the LabVIEW side, it invokes this Python application. Python application connects to LabVIEW and is waiting for commands. And then the commands invoke sort of a Python function that can interact with the selection and the entire application, in fact, and then do the work based on the prompts that have been coded up for that specific action. And then this little helper tool, this little sparkle, is part of our integration tool that exposes the set of commands that are available for a given selection. So
I'm
it's,
gonna jump in right here. Michael raised their hand in Zoom.
yeah,
Um,
Yeah.
and I wanted to take this opportunity to say, if somebody has a question, just like jump in. Like that's part of the format, is like interrupting and switching the time back and forth.
and I
Um,
can't see
Yeah.
everybody on here either. So yeah, go ahead.
yeah, yeah.
Yeah, two questions. I think this is that's what you use is function calling and
It's called
Open
function
API.
calling tools. Yeah.
Yeah,
Mhm.
yeah, exactly. And the positions that you get back from OpenAI, does that make sense? Is it if you look at that visually, are that
Yeah. So
correct positions? Or
let's,
is it-
I'm going to select both of these here and then do a cleanup and we'll see how it does. And how well it does is very dependent too on the prompts, the rules, and how specific we are. I notice it runs a bit slower when okay, there we go. When we're doing the screen sharing, because it uses a lot of my CPU.
Yeah, just with all the waiting, I've dug into the question and answer time a little bit just to let you get through some more of the
Sure.
demo.
So
But
it does work pretty well. Yeah. Any more questions?
yeah, we've
Did
got
you also
about
play
3 minutes left.
local LLMs? You can
Um,
also
I have not gone there yet because it's still kind of experimental mode. I guess the benefits of the local LLMs is you can iterate, kind of, you can have a lot more transactions very, very quickly. However, presumably like the quality is lower and the speed of
yeah.
response is also a function of how many GPUs you have.
Question I have is, what are your goals for this project? Like, what would you like the LLM to help you do?
So that's a really good question. I think right now there are certain automation tasks, like for example, when we're editing icons of our nodes, because we can actually use this code that I'm creating and use it as a submodule. So being able to suggest iconography, for example, like this is a little zip thing. We've done experimentation with having a little sparkle button that suggests glyphs based on the name and description of the function. And it'll just, once you choose it from the sparkle, it'll just add the glyph. And it does that by querying a local library of glyphs that have names and tags. And then it sends that list to the LLM along with the description and name of this function, and then asks the LLM to suggest which of these glyphs would be the best, most appropriate, and then we can programmatically add them to the top. So I'd say little things like that could be a lot easier. But I think a lot of this is really kind of like foundational technology for a lot of other things. I'm very, very interested in like having these text-based representations and then asking LLMs other kind of high-level questions like, is there any way that this function call, which takes string data, can receive string data that's user input, and have like the LLM do intelligent traversal to determine, for example, if there's a prompt injection attack or something like that. So I think this is exploratory. Another goal is to introduce our LabVIEW community to LLMs and the ability to do interaction. So what I'm very interested in is to expose some of the under the hood prompt and even tool definitions to end users so that they can start doing prompt engineering to automate certain tasks in the IDE themselves, or even build other tools, because we've done a lot of work to kind of bridge the hard parts that aren't like directly accessible to most LabVIEW developers.
Cool. That's our time. Jim, thanks for the presentation.
Yeah, thanks,
Always
everybody.
cool to see people doing visual programming stuff. That's like my favorite. So
I look forward to participating more. Thanks for the invitation. And I apologize, I've got to actually run because I've got
Yep.
to
All good.
Thanks, everybody. And thank
Thank
you
you.
for letting me go first. Bye-bye.
Yeah.
Yep, no problem.
A cloud of hearts floats by, Kartik. Konrad, you're up next, I believe.
Yes, I think so. I'll try if
Excellent.
my screen sharing actually works.
I've got the clock reset.
It says
And,
desktop one. Can I just
Yeah.
do... Okay, I share my whole screen and switch images. It should work. Let me see. Do you see something like...
Yeah, we saw some cool patterns. Now we see quick Lisp. And just to encourage folks following along, do be rude and interrupt to ask questions. That kind of frequent back and forth sort of choppiness is an intended part of the format, and it works pretty well if people get into the flow of jumping back and forth. So don't be shy about interrupting. That's
don't
that's
hesitate. I'm used to it. So to set the context, my goal in life is to make programming more accessible to ordinary people for their own purposes. So I'm interested in things that are called end-user programming, although I don't like the term. I like more the term of situated software. I would like to encourage people or make it easier for people to write situated software for their own needs or for the needs of their family, their colleagues, their team, and so rather than as a product sold to somebody else or to a wide audience. And one issue there is that you want something, you want to use libraries, you want to use established language because you can't start from scratch every time. On the other hand, you don't want to use the typical user interface designing toolkits. So what I'm proposing today, what I'm showing today, is a demo of something which I've already mentioned in the Slack, and I've sold this as an object inspector for Common Lisp. But it's really what I want to show today is that it's actually a kind of GUI toolkit, and can be used as a kind of a very constraining GUI toolkit. But as a compensation, it is much easier to develop visual representations of data, and they're actually composable. So you're not in the app trap where you know that the typical GUI is something like somebody designs a complete app from scratch and the code behind it, you never see it. And that's not what I want. I want situated code. I want people to see the code. It's just an interface, another interface to the code in addition to REPLs and whatever else. So yeah, in this thing, every pane is a view of some object, and this object here is just a fake object I make because QuickLisp is the Common Lisp package manager, the most popular one. So you don't need to know much about QuickLisp, but I'm using it as a demo. So QuickLisp as a Lisp interface, an API. You can use it in the REPL, and that's it. And it's actually very well designed and very badly documented, which in the Common Lisp world is pretty common. So what I did is to so you don't want to look at the list of packages in QuickLisp, which is 2,000 packages. You don't want to look at this on a terminal. That's absolutely not useful. And especially in particular, when you use some multiple distributions, I can make this larger. So I have two distributions here, the standard QuickLisp and UltraLisp, which is bleeding edge stuff. So what I have here is simply a view, which is very, very trivial. It's an HTML table with two columns, right? And it shows me the available software in QuickLisp, and then I have no idea what these things are. So I can open a specific one. This defines two systems. This is Common Lisp stuff. I don't want to go into the details. You can look at the definition files, but this is not a good example because I actually don't have. I have to install it first. So this actually. Install is the QuickLisp term, right? I didn't invent it. It just it downloads the whole stuff to your local computer. That's all it does. And now I should be able to browse these files. Yeah. So if you know Common Lisp, this tells you something. Otherwise, it doesn't. But this is the source code that defines a package in Common Lisp. So so all these things is just views, and there are buttons. So you do things via action buttons. Now, if you want to know what an action button does, you alt-click it. And actually shows you. No, I alt-clicked on the wrong plot there. This is another. Something I wanted to show later. So this is what I wanted to do. It's a bit difficult for me because the Zoom user interface hides my screen. So I'm kind of navigating blindly here. So this is the code that is run when I click on this button. So it's never hidden from you. If you want to know what things do, you just alt-click things. And similarly, you can alt-click the whole pane. And then you can inspect the HTML behind it. This is the title bar, the individual views here. You see every tab here appears here, and I can again show how this is constructed. But I can also give you the HTML code that is actually generated and that is actually displayed. And I can also now this is I'm using as a baseline a system called Clog, which is the Common Lisp Omnificent GUI toolkit. I'm only using the lowest layer of it, which is basically.
I've got a question.
Yes.
So all this code is in the package for 3D math. So the configuration.
Oh yeah, what I'm showing is no. 3D math is just this one. No? This is the 3D math, and now I did alt clicking, so I'm now diving into my own user interface. It's introspection of my own user interface. So here it was still standard. Here, this is the 3D math. This is the files that it loads. So this is the code. You can go in here and look at the Lisp code and so on. So you can browse the package, but you can also browse the class then. But this is just a standard Common Lisp object inspector. So there's nothing really exceptional. It's a nice one, but well, it doesn't do any more than that. But the idea is that you can actually add items. I put my action buttons up here. I could also put them in the HTML. So I can add things, and the combination of plain HTML views and simple buttons for launching things, that is actually quite a lot. That has allowed me so far to do everything I wanted to do. There's another one. I can type Lisp code here and run it on my object, but I'm not going to go into this. I can also run methods. Again, I would have to explain Common Lisp to really show what this is, but this is the kind of functions you can run. You can run immediately and see the output. But
I'm going to interrupt and ask a question, just a kind of a like understanding what we're looking at sort of question. Looking at this, I'm reminded a little bit of Smalltalk, for instance, the sort of the browser interface. And I'm curious if is that like the closest kind of comparison, the most similar sort of frame of reference?
It's the closest inspiration because I'm still using Glamorous Toolkit, which is a new Smalltalk user interface. And this is kind of a copy of a subpart of Glamorous Toolkit transposed to Common Lisp so that I can use it for things for which I cannot use Smalltalk, and in particular run it on Android devices. But yeah, it is very Smalltalk inspired, definitely, yes.
Cool. And is this an environment that is also, like if you're using this environment for your own explorations, are you actually writing code in this environment, or is this an environment that you use?
Oh no. I mean the code is here. It's Emacs with Slime. So I'm just here. I'm running my inspector, and that opens a tab on my browser. So these are two different worlds, but they interact. In the long run, yes, I hope to have better code editors in there and actually be able to code in there. But for now, it's just an extension to Emacs. Yeah.
And then one other kind of related question, just frame of reference sort of thing. One of the things about Smalltalk is that authoring environment, the browsing environment, is also a little bit like your runtime, and there's a sort of a blurring of the boundary there.
Oh yeah, definitely. That's true here as well. Yeah.
True here as well.
But that's
so this
true for
is the
any Lisp
environment where the
customer, I would
code
say.
is.
Yeah.
Yeah. I'm just curious how how much that's the intent of this environment is to also be the
Oh,
environment where
definitely,
the
yes.
code is running.
You're living in your environment and you're extending it. There's not, you don't write programs. You can, in Common Lisp, you can write scripts and so on, but contrary to Smalltalk, but it's not what people do most of the time. It's a side product. You typically
Yes.
work in such an environment. At some point, you may say, okay, this functionality is something I want as a script, and then you compile the stuff down to something to an executable. So that's doable, but not my goal, let's say. So
Cool.
my goal
Okay.
is really to have a different to propose something in between a complex GUI toolkit and a command line text interface. And the one thing that's worth looking at here still is what I haven't shown that much yet is how much work is it to write such things. So I can also alt click the tabs, and this is the function that produces this view here. So given a quick list object, that's just something, it's a class and so on. This is what it does. So it's Clojure people may recognize the threading macros. They also exist for Common Lisp. So it's just a series of steps. You ask quick list for some information, and this is just some data munging. And in the end, I said I want a multi-column list view. I have 2 columns, and each column has a piece of code that this is the object that is displayed, and that's it. So of course you need to learn a bit of this language as everything, but all those views are simple. They're not complicated. And what it boils down to in the end, if you write one from scratch, is this one. This one is actually HTML code, you see. So this is HTML as Lisp as expressions. So it says small class inspector for CSS. Here's a table, and you have a loop, and you do TD elements. So this is just if you know HTML, you know how this works. I could show this one, the versions one. So that's what it looks like. So this has
1
actual
minute
links.
warning.
So these are links. Yeah.
Oh, this.
No,
Yeah,
I'm pretty much done. So this is an HTML view where you actually have links to the outside. So each of these things opens something outside on the quick list side. And yeah, what can you do with this is quick list. I made another one for browsing the installed packages in a running image. But again, it doesn't make sense to show off this unless you know Common Lisp. A more interesting one is perhaps this is the user interface for my blog, my own blog generator. So here I have posts, and I can inspect a post, and this is the source code of the post, and this is the preview of the HTML. This is generated. This is the HTML generated from the Markdown, and so I can, if there anything is weird, I can see what happens, and then I can say, or build and publish it on my website. So this is basically all I need to work on my blog. And it's a one-pane GUI, and it's not something I would do with standard GUI tool. It would be too heavy, and here it's pretty trivial operations, all of this. Okay, that's it.
Yeah, very cool. We've got a couple minutes for questions left, and I'm going to kick off with one, which is, Konrad, are you brave enough to make this the actual deployed interface of your blog? To push this to the web as the interface for the viewer and really put the end user malleable software.
Point of view, yeah, I think from a security point of view, it's not a good idea to put any of these things on the internet, because behind this, you can run Common Lisp code on my machine, and you can delete all the files in the home directory. So the answer is no. I'm playing with the idea of having it on my local network and set up something like Timescale, a secure network among my devices, and there I would put it on, yeah. But as the interface to my blog, definitely not, no.
Yeah, there's just looking at this, like, it's a nice list of posts, and there's a little bit of styling to it, and there's sort of the rendered version versus the source version. It feels like a very programmery sort of website interface.
I could, if I get rid of the playground views, basically, I think I could. This is the dangerous part. This is what lets you type arbitrary Lisp code, and that I can't do. But I could actually imagine taking these out, and also the operations that can go too far, because you can run any method implemented on this a code you can run here. And again, this is too dangerous.
Yeah.
But I think the others, I could probably do that. Yeah.
Yeah. No, don't do it, because all the software is written with some assumptions, and the assumptions are all over at all levels of abstraction.
in particular, I'm not terribly sure of what the hidden assumptions of clog are, because again, the clog author says clearly, I see this as a GUI layer on top of Common Lisp. You can put these things, you can do web apps, and he has a special module for web apps, and there's a lot of security stuff in there. I'm not using it, so I guess there's a reason.
Okay, yeah, that makes sense.
Before we're out of time, I'm curious if we can jump back to those that data binding visualization transform that vectorized operation used to generate the HTML table. Because if I was using this for visual programming, right, my assumption was, oh, I have to go through with some kind of plot library that's going to package everything up into a neat 15-line block. But the impression I'm getting is this is generally open-ended Lisp code,
Yes.
and we can spin out. I happen to know the D3 syntax for making complicated SVG plots with like 9 kinds of elements. And that's the future I'm envisioning with this kind of rich input widget to make not just to make the buttons, but to have diagrams, to have drag and drop interfaces, stuff like that embedded in this live playground.
You can, for example, no, this is not the right one. You can, for example, you can do graphs in there, right?
Okay, yeah.
And for now, this is just, well, this is just an SVG, and it's
Oh, it's a
generated by
beautiful
GraphViz.
layout. Yeah, but that's what I'm expecting, the SVG as the target embedded in the HTML. That's very cool.
Exactly. I mean, this is just there's a feature added this week, so this is not really performant yet. For now, you can only generate SVG and show it. I want to make these things clickable first of all. That's something I roughly know how to do. And ideally, I would integrate editors. And yes, the idea is to be able to do visual things. I don't like the term visual programming. I don't know what it means, so I don't use it. But I would like to do, let's say, have editors for graphical information inside this and be able to use them in other code, but this is not done yet. Yeah.
Brilliant. I look forward to further developments. Thank you.
Super cool. Thank you, Konrad. That was a fun demo. Now I just want to go alt click on everything. See where it takes me.
That's the real thing is alt clicking. That's what gets you the interesting stuff there.
Yeah. Very nice. And for our final demo today, it's Kartik, is that correct?
Yep, and it's not a demo. So for
all
this
right.
one, I thought I would, I've done demos before. I've kind of bored people with like things I've built. I thought I'd try something different today. So let me share my other screen. So this whole thread of thinking was inspired by a thread on the Slack channel where we discussed problems. To back up for a second, so in Konrad's demo, he talks about a solution that he has, and he grounds it in this idea of situated programming. And I thought I wanted to go up one less step further up than situated programming and say, what is that or other things like that potentially aimed towards? What's the goal? When I look around, everything we do in the Future of Software forum, to me, it feels like we're trying to invent the future. And there's this quote about how you can't predict the future, you just invent it. But I think you also need to persuade people to your invention. And I think we all do a really good job inventing little pieces of the future that will influence things downstream in ways big and small. We haven't done very well at collaborating, at persuading each other or being persuaded by others to join forces. And I feel like maybe if we switch to thinking about problems rather than solutions, that might help. So this picture was sort of something I sketched out based on the thread in the Slack channel. And I feel like I came up with a list of all the manifestos people wrote and what problems they were trying to solve. And it seemed like this one in the middle. Can y'all see my mouse pointer?
Yes.
Nope.
Can you wiggle it around? Just
It comes in, yeah.
It's updating.
So this central thing, we want more agency from our computers. I think that's what situated software is really like aimed towards, and lots of other approaches too.
Sorry, Kartik, I think your video might be frozen. Can you move your mouse pointer just so we can see it moving? Yeah, I don't see it moving. Yeah.
I'm
No, I don't
sorry.
see moving either.
I'm sorry. I'm confusing myself with two screens.
Aha, there we go.
Ah,
Yes,
there we
that
go.
is a mouse pointer. All right.
Okay, that helps. So this central node, it feels like we're aiming towards having more agency with computers. And let's think about this picture now from the perspective of someone who's not tech savvy to begin with. Why do people feel a lack of agency? And one thing I want to say is, by the way, when people complain about, oh, the UI is not good, they're often talking about a lack of agency. It's not just something about what's shown on the screen, but the problem might actually lie deeper in the information architecture or the assumptions the programmer is making about who it's for and things like that. Similarly, when people talk about poor models, I think the fundamental problem complaint that people are really aiming towards is a lack of agency. Now, what are some reasons we might have lack of agency? It might require a lot of effort to get this piece of software to do what you want it to do. You might have lots of silos. Each of them is a separate app, and you feel like you want something from this app and something from that app, and I wish I could do them both together. Making changes, like interacting with a piece of software, can be scary because we know that software can like brick your machine or brick the thing. So you get into a sort of unrecoverable state at some level where the thing you use to make the change is no longer a thing you can use to recover from the change. You need to go down one level somehow. And then, of course, there's an increasing danger that more and more people are aware of getting hacked, whatever that means. Somebody else can control your computer. One of the problems with the lack of agency is people, the end users, the owners of the computers, have less agency because they depend on vendors for software, and the vendors are constantly competing for agency. And all the vendors, in part, are also contributing to these other problems, which is software is inefficient, the software has bugs. So just zooming out to the whole picture right now, that's kind of, when I look at all this, it's pretty daunting, right? As a layperson, how do you get more agency on your computer? We're pretty far away from that sort of utopian goal. If I make things a little bit easier and say, okay, I'm a programmer, I have a certain amount of tech knowledge, and I look around at this picture again, it doesn't improve that much. I think a lot of these still apply. They apply in slightly less draconian ways. They seem like smaller problems if you have some basic knowledge. For example, they require lots of knowledge. I still require a lot of knowledge that I don't have to have agency over my computer, but I have some basics, and that helps a lot. That gets me at least to the foothills. So I'll take a break there. I've been talking for a while.
Okay.
I want this to be really interactive, and we can have more than half time for questions.
This is super exciting. So let me throw in the layers of abstraction as kind of this definition of agency you're working with. I'm going to challenge that and say programmers tend to go up and down in 3 levels of abstraction when you're dealing with any given system. That's more than most people are going to deal with in their role at the firm that's actually responsible for, that's actually the user of the software. So I think the biggest threat to agency is not merely that we have somehow the vendor is going to slide in a layer of abstraction above what you've already been doing, which obviously is what's happening with GPT, other God tricks. Oh, this will run everything else for you. Don't worry about it. That's as a consequence of the structure of the organization being designed to split up responsibilities at this. Oh, I deal with one level of abstraction. You deal with the next one down. You deal with the next one down. Nobody is going to try and cross-cut vertical because it's too hard to replace those people, cynically. And therefore, there is this pressure, not that anybody's actively trying to do this, to have the programmers who have this vertical slice through layers of abstraction to make sure they're siloed in a way that this isn't critical. This is its own module. It's not cutting across too many different verticals of the organization. It's just sitting at the end of one of these knowledge transfer lines. I'm using a transit system metaphor. And that means you can always redirect that train to a different station. Does that make sense?
Kind of. So that's a very different way to look at this picture, and I appreciate
Yeah.
it. I think when I try to adopt that frame of abstraction, I kind of start with a very different axiomatic premise than you. So I'll make this claim. The key skill of a programmer is spanning levels of abstraction. To the extent that we can do that, the best programmers span a lot more levels of abstraction than somebody new who's like stuck in one module.
Definitely.
I'll also say that a big problem in our world today, which contributes to this lack of agency, is a proliferation of layers of abstraction. You mentioned ChatGPT, but I'll make a simple example. When you go to the Twitter website, it started out as a reverse chronological flow, and then they gradually added more and more knobs to it that only they had access to. They basically inserted a layer of abstraction without changing the UI at all. And so there's huge pressure from everyone in the world to constantly add layers of abstraction. And that's not going to go away anytime soon. I think that's like just part of reality.
Okay.
And so when I think about giving people agency over computers, the way I would think about it is in the real world, when things break, I need to dive down one level of abstraction and diagnose what is this thing made up of? And I think we want to give those capabilities more broadly to everyone. I want people to be able to choose what layers of abstraction they are adopting when they get the computer, because it has all these layers, and I choose not to use this, this, and this. And I want people to understand, who do I go talk to about this piece? How does this decompose into these things? How does the on the computer translate into people and relationships?
Exactly, but let me split that into your audiences here, because you have the kind of user who, this is their permacomputing, this is my exobrain, and I'm going to carefully curate what stacks I have programs on my machine. But when I go to work, I can no longer do that because I'm forced to open my colleague's Google Doc in order to talk with them. And all
Do
of
you
a
say when you
sudden,
go to the web?
well, as soon as I'm in the workplace, right? This doesn't arise from, this arises from the intranet of the organization I'm part of. So just from the perspective of making these tools for work, we can no longer hold to these very strict permaculture ideals. I mean, to some extent, this is, I mean, the stories I've heard about Google's internal infrastructure, it's one mono repo. That sounds very much like a utopia built for programmers. This is maybe not entirely compatible with the non-engineering side of the organization, mind you. But it does seem like an environment where they've created the Google-sized version of permacomputing. And that is going to look a little different than the individual-sized permacomputing, the academics institution-sized permacomputing, and whatever other org-wide solutions we're going to inevitably deploy to facilitate collaboration, I believe.
Yeah. So I think all that is true. And like, I think what I'm trying to do with this diagram is not make any assumptions about the world I'm in or the world I want to go towards. So yes, there is a world where like it's very perma-computing and people are working as individuals. There's the world where you're stuck inside an organization and certain policies are applied to you. I think regardless of where you are on that spectrum, certain things are true, which is you have more agency if you understand where the policies are coming from. So if you just think of, oh, the company has these policies and they apply to me, that's one level of, sorry, say that again?
Yeah, I agree. If you don't have organizational transparency about why this policy is being applied to me, then you break down, then your agency breaks down promptly.
I'm not even talking about agency transparency from the, so forget about what the organization needs to do, because I as an individual don't control that. All I'm saying is it's knowledge. It's all different kinds of knowledge. I want to learn more. So you get agency by getting knowledge, and you use the knowledge you have in ways that can improve your agency downstream. So there's a sort of feedback loop there.
Can I jump in and ask a framing question? We've got about 3 minutes left. It would help to hear in 15 seconds or so, Kartik, restate what your goal is with this diagram and presenting it with us. What are you attacking here?
So it is kind of getting into the next slide, but the goal is we're all off doing our solutions, and we're all off implicitly attaching ourselves to different parts of this diagram, I think. And I think there are probably parts of the diagram that I have not written yet. So if you have a goal and it's not on here, I want to hear about it. I think when we look at the solutions, it's very hard to see that two solutions are attacking the same shaded parts of this diagram. And if we were more explicit about communicating which parts of this diagram or a map like this we are attacking, it might be easier to find opportunities for collaboration. And I think the producers have to collaborate first before we can try to find collaboration with consumers.
Cool.
Mhm.
Did you say you had another slide to show? Because if so,
Yeah.
we should do that
Yeah.
because we've got about 2 minutes left.
Yeah. So I'm going to stop sharing. This is going to be clunky. Then I'm going to open a new one. Then I'm going to start sharing again.
And also at some point, maybe in a after session, after the meetup formally ends, we could take a couple minutes to chat. But I feel like there's a second diagram entirely that would be a good precursor to this diagram, which
Okay,
is the
awesome.
like, why are you even in the community diagram? Is it because you want to be building a solution to these problems, or is it for one of many other possible reasons?
I see, I see. Oh, that's a good point. Yeah, I think I might have started out with some initial assumption there. So this is the exact same picture as the previous slide. It's just got some edges in it. Okay. And so
Okay.
what I tried to do is highlight the shaded parts in my brain. So those are all the problems everyone's talked about, but these are the problems that I tend to focus on. What I tend to focus on most is the problem of too many vendors. And so that has some connections through inefficiencies, through bugs. And I also think about the effort it takes to program. So I have some interest in improving debug UIs and stuff like that for myself. And this is all very much in the frame of what somebody called end programmer programming. Oh, it was Steve Krause. Steve Krause.
I think it was Jonathan Edwards originally.
Oh, interesting. So end user programming seems hard. For end programmer programming, that's also pretty hard. And this is the subset of it that I tend to focus on. And if I tell people that, and now somebody else has noticed that they have overlaps with that, then come talk to me. And I want to create a single shared diagram that plots at least our like most active community members on it and gives people a starting point for saying, hey, who should I talk to? So that's basically what I have. I have another diagram that I can show later about like the idea maze that I see, but that's for like, again, getting more specific. So it's only of interest to people who have overlap with me.
Cool. So this is, just to kind of put a bow on it, a map of the sort of problem areas that different people in the community could be working on, and your
Yes.
attempt to try and find some common threads between those
Yes.
problem areas so that there's room for collaboration and sort of shared effort, or at the very least, you know who to get together with and kvetch and have a
That's right.
have a misery party,
Yeah,
misery
and-
party.
So the interesting thing is, no, actually, I completely agree with that.
Cool. And
Any
well, that
other-
brings us to the end of our allotted time.
Awesome.
If anybody wants to stick around and keep chatting more informally, by all means, welcome to do that. I'm gonna stick around for probably another 15 minutes or so. But yes, thank you to everyone who presented today, and thank you to everybody who came out. And we'll probably do another one of these in a month. Seems to be a good thing
Yeah.
we've got going.
Yeah, thank
I will
you.
post something on the Slack today or maybe tomorrow on the
Cool,
on
yeah,
the-
present
what
company.
is it? Yeah, exactly. That's one.
Yeah, maybe try and pick a slightly different time just to pull some different people out for the next one.
Yeah, I try to keep it open to give people to let people give some suggestions. But yeah. What would be a good time?
Yeah.
For me, it's 6 o'clock, 7 o'clock in the evening currently. For you,
Yeah.
I think it's in the morning. Currently,
Yeah. For
I don't know.
us mountain time folks, it's 11 a.m. I think for people on the west coast of North America, it's starts at 9 a.m.
Ivan, did you want to stop recording?
Yeah, sure.